All right, well, hello everybody. This is your teacher, Mr. Santillana, and these are your notes, 3.2, 3.3. We're going to be talking about proofs and to use this, proofs with parallel lines. Okay, so the first thing you need to understand is what exactly is a conditional statement versus the converse. Let's take a look at an example. Okay, if we say that the measure of angle A is 65 degrees, then the angle A is acute. This is what we call an if-then statement. The if statement is what holds the hypothesis. The then statement is what holds the conclusion. And this, in fact, would be a true statement. If measure of angle A is 65 degrees, then angle A is an acute angle. Now, what is the converse? Take a look at it. What we do with this is we switch the hypothesis with conclusion. So we say if angle A is acute, then measure of A is 65 degrees. Now notice that, is that really a true statement? If angle A is acute, then the measure of A is 65 degrees. Well, not necessarily. If an angle A is acute, it could be any measure less than 90 degrees. So it doesn't have to necessarily be 65. So in this case, we would say that that is false. So sometimes the converse of a statement isn't always true. Let's take a look at another example right down here. What if the measure of angle A is 90 degrees? Then we can conclude that angle A is a right angle. Okay, is that true or false? Well, that would be true. Let's look at the converse. If angle A is a right angle, then measure of angle A is 90 degrees. Yes, that would be true. Okay, so that's what we call a biconditional statement. This is a good vocabulary term to note. It's when both the conditional statement and its converse are true. Here's an example, right down here. The measure of angle A equals 90 degrees. Measure of angle A equals 90 degrees if and only if angle A is a right angle. Okay, so now why did I go over this? Because I'm about to go over several theorems. Now, please understand that these are a total of 8 theorems and postulates, but it's really 4 concepts, and each one comes with its own converse. So the first one is the alternate interior angles theorem, aka theorem 3.1. The converse of that theorem is theorem 3.5, which I'm not going to write down because it would be me writing the exact same words, just switched around. Okay, if a transversal intersects, that's the symbol for intersects, 2 parallel, that's the symbol for parallel lines, then the alternate interior angles are congruent. Okay, you knew that already, though. Theorem 3.2 and its converse. We're talking about corresponding angles. Same deal. If a transversal intersects 2 parallel lines, then corresponding angles are congruent. That's the key here, they're congruent. Here is theorem 3.3 and its converse. And again, if a transversal line intersects 2 parallel lines, then those alternate exterior angles are congruent. But we knew that already from a previous set of notes. Here's what's interesting about this theorem. It's not really a theorem, it's a postulate, 3.1. We can discuss this later. We're talking about same side interior angles, also known as consecutive interior angles postulate and its converse. But notice that its converse is actually a theorem. Yeah, how weird is that? Okay, if a transversal intersects 2 parallel lines, this time those angles, those same side interior angles are not congruent, but they are supplementary. That's the one that's different. Okay, why do we go over these 4 theorems? Okay, this is where my moment comes up. Because you are going to be working with proofs. And sometimes you are going to be given in a proof the fact that you have parallel lines. And you're going to be asked to prove angle measures. If this is ever the premise of your proof, you're going to use these 4 properties. These are the 4 properties that you use to solve them. However, if a proof is giving you an angle measurement and you're being asked to prove that the lines are parallel, so it's backwards, then you're going to use the same four relationships as above, except you're going to call them something else. What are you going to call them? This is what you would call them. You would call them converse, I'm going to put quotation marks around that, converse of ... and then you would fill it in with whatever theorem or postulate you want to use. Here's an example right down here. Check out this example, the converse of the alternate exterior angles theorem. You will be able to learn this more precisely when we do some examples in class together. Okay, thank you very much.